Namaste. Welcome to our YouTube channel. So today we are going to discuss question number 6 from PSA 2024, where the question is quite simple. We need to find out the number of elements in the set S, where S is the set of all such 3 cross 3 matrices A, for which A square is 0 and all the elements in A will be either 0 or 1. So first, we do a simplification of the problem where we are partitioning the matrix A into a 2 cross 2 matrix A1, then column vectors A1 and A2, and a scalar A. You can check whether the order is preserved here, like whether this is the right partition for a 3 cross 3 matrix. And these are the notations for our column vectors and the A1 matrix, right? Which is the step 0 of the problem. So moving forward, the first thing we need is we need the expressions for this matrices. Why? Because if A square is 0, the next thing that we get is this is equal to 0, which means that each of the expressions will be 0, which further means that A1 square is 0, this is 0, and each of the matrices will be null matrix, right? Now one thing, if A square is 0, then what is A square? A square is this, and we know that all of these terms are non-negative because we have only possible choices 0 and 1 to put here. So since this is also non-negative, and this is equal to 0, we must have E1 square is equal to 0 and E2, E3 is equal to 0. Similarly, E4 square is 0 as well. Hence, E1 and E4, they are 0. Now, E2, E3 is also 0, which gives us that E2 and E3 both cannot be simultaneously 1. Our choices can be E2 0, E3 1, or E3 0, E2 1, or both are 0. So, moving forward to the step 1 of the problem, A1 square is of this form, right? And we already know this. And using that, we can say that A1 has only these 3 possible choices, right? Now, if A1 has only these 3 possible choices, what about the possible choices of small a1 and small a2? We know that small a, that scalar, will always be 0. So, we will focus on the possible choices of capital A1, and small a2. So, for this particular choice of capital A1, what could be the possible choices of small a1 and small a2? Now, it's quite simple that from these 2 conditions, we do not get anything additional because capital A1 is 0. So, this 2 will always be 0. But in this 2, we see that B1, C1, B1, C2, B2, C1, B2, C2, they are 0. So, if B1 or B2, any of the elements in B from B1 and B2 is 1, then C1 and C2 both has to be 0. Similarly, if C1 and C2, any one element of C1 and C2 is 1, then B1 and B2 both has to be 0. Otherwise, this cross product terms will never be 0. So that is why these are the possible choices, and 2 additional choices could be this, where B1 and B2 both are 1, and C1, C2 0, and C1, C2 both are 1, B1 and B2 0. So the one condition is that we cannot have 1 simultaneously from the vector A1 and A2, right? If any element of the small a1 vector is 1, then all the elements in small a2 vector is 0, and these are the possible choices. Similarly for this, what are the possible choices? So for this, we do get this 3 possible choices only. Why? Because see, if this is E2 is 1, then from this 2 condition, we see that C1 E2 is 0. So if E2 is 1, C1 has to be 0, right? Similarly, here we see E2 B2 is 0. So if E2 is 1, then B2 also is 0. So we have 2 additional constants, that C1 and B2, they are 0. Keeping C1 and B2 0, what are the other possible choices which also satisfy that we cannot have 1 simultaneously from both A2 and A1? This 3. Alright. So after this 3, similarly we can get 3 conditions which satisfies this, which are this, right? So how many total possible cases we are getting? This is 13, including the null matrix. Now one thing, that in the option we do not have 13, right? So this seems weird, but we have 12. Apparently they are not counting the null matrix, but it is not mentioned in the question, so we can say the answer should be 13. What do you say? And if you like this video, smile at some stranger today. Hare Krishna.